IFN gamma is a cytokine secreted by Th1 cells and NK cells. IFN gamma helps fight viral infections by activating macrophages. In this video, I'll share my visual mnemonic to help you remember all the information about IFN gamma so you'll be ready for test day.
Commander, sir, we're getting major interference in our control of the gamma ray.
Oh geez, see how this screen is all garbled up with static interference? I guess some bad guys are trying to hijack our command center. By the way, this interference helps me remember interferon, since interference sounds like interferons, right? And what about that gamma ray? Notice how the gamma ray even has game-like controls. Well, obviously, both the game-like controls and the gamma ray should make you think of the Greek letter gamma. Get it? Game or gamma rays for gamma? Putting this together, this interference in our gamma ray should help you remember interferon gamma, shortened as IFN gamma. Makes sense, right? IFN gamma is an important cytokine with important functions. Let's explore the rest of this scene to learn all the functions of IFN gamma. Aha! I found a virus in the machine, so that's where all this interference was coming from. Some bad guy must have infected the controls here with a virus. Anyway, this computer virus actually helps me remember that interferon gamma plays an important role in helping our body fight viral infections. A computer virus for viral infections. Get it? Interferons as a class were named as such due to their ability to interfere with viral replication. The antiviral role of IFN gamma comes in part by its ability to inhibit viral replication directly. However, in addition to its direct antiviral effects, IFN gamma, more importantly, fights viruses by activating other immune cells against virally infected cells. So where does all this IFN gamma even come from anyway? The bad guys got in a scuffle with our ship crew earlier, and it looks like some of our officers need first aid. Fast. But wait, these are not ordinary first responders. Since we're on a spaceship, we call them first helpers instead. Do you see his first help kit? By the way, the first helper coincidentally helps me remember T helper cell type 1, or Th1 cells, because first reminds me of the number 1, and helper reminds me of helper T cells. So, first helper for Th1. Get it? This matters because IFN gamma is produced by Th1 cells. Recall that Th1 cells are a subtype of helper T cells that coordinate immune responses against intracellular pathogens, like viruses. The Th1 cells use IFN gamma to coordinate a concerted response against the threat. We already know that interferons are an important signaling molecule during viral infections, so it makes sense that IFN gamma is produced by Th1 cells. Next, notice the nuke explosion on the screen. Oh man, it looks like the bad guys have already succeeded in hijacking this gamma ray. When this gamma ray fired, it caused a nuclear explosion on that planet. Speaking of nukes, doesn't the word nuke remind you of NK cells? Because nuke sounds like NK, and it even has the letters N and K, right? NK, or natural killer cells, also produce IFN gamma. Recall that NK cells are innate immune lymphocytes adept at killing virus-infected or cancerous cells. They also produce interferon gamma, which helps to fight viral infections directly and indirectly by activating other immune cells. We'll talk about what these cells are in our next symbol. So we've learned that IFN gamma comes from Th1 cells and NK cells. But what does it actually do? Take a look at the giant cage over here, holding the bad guy. Yep, we have caught the villain and locked him up inside a cage. This cage, or macro cage, is our recurring symbol for the macrophage. Get it? Because macro cage sounds like macrophage. And macrophages work by ingesting or trapping stuff, similar to how a cage works by trapping things. We're talking about macrophages here because IFN gamma activates macrophages. The activation of macrophages by IFN gamma enables them to phagocytose stuff and secrete inflammatory cytokines. Since the phagocytosis and inflammation helps in the immune response against viral infections, in concert with the action of NK cells and killer T cells. We have a whole scene you can watch dedicated to macrophages. Additionally, activated macrophages secrete IL-12, to stimulate Th1 cell production. Recall that this was the cell that made IFN gamma to begin with. This positive feedback loop serves to amplify the immune response, recruiting an army of macrophages and Th1 cells. This signaling axis is also particularly important in the pathogenesis of granulomas. You know, granulomas? I'm talking about the pathologic finding of a core of macrophages and pathogen surrounded by a collar of lymphocytes. When our immune system can't eliminate a pathogen, it does the next best thing. It walls it up into a granuloma to keep it from spreading. The formation of granulomas in diseases like tuberculosis is hugely dependent on macrophage activation by IFN gamma. Finally, take a look at the commander of the ship here with a mohawk. Actually, everyone's got a mohawk here. These space sci-fi people always have weird haircuts, like in Star Wars and Star Trek, right? Coincidentally, mohawks are also our recurring symbol for MHC, since mohawk sounds like MHC. Get it? It's the MHC mohawk. The mohawk here should remind you that IFN gamma increases MHC expression. Recall that MHC are cell surface complexes responsible for presenting antigens. IFN gamma increases expression of both MHC1 and MHC2, with the end result of increasing antigen presentation by all cells. This increase in antigen presentation is important in mounting an adaptive T-cell response. MHC1 in particular is used to present intracellular proteins, such as those created by viruses, to cytotoxic T-cells. A cytotoxic T-cell recognizing an abnormal antigen on MHC1 would then kill the virally infected cell. So it comes full circle. IFN gamma increases antigen presentation, which enables T-cells to mount more immune responses against pathogens. Alright, that's it for IFN gamma. Let's recap quickly and get off this ship. Interferon gamma, or IFN gamma, is a cytokine with major functions in the defense against viral and intracellular infections. IFN gamma is primarily produced by Th1 cells and NK cells. IFN gamma then activates macrophages, which work to fight the threat. Activated macrophages also contribute to a reinforcing feedback loop, since macrophages make IL-12, which stimulates Th1 cells to produce even more IFN gamma. This amplifies the overall immune response. Finally, IFN gamma increases MHC expression in all cells, which increases antigen presentation and T-cell activation. And now we're actually done with IFN gamma. I've got to get back to my battle station. I'll see you in the next battle.